Just to wrap up this quick survey of organic chemistry, I do want to mention just a few of the common or typical organic reaction types. So, for example, there's combustion. This happens when an organic molecule reacts with oxygen gas. This is typically what happens when you burn things like methane or propane or even paper. The most important thing to note is that the organic compound consists only of carbon and hydrogen, or carbon, hydrogen, and oxygen. Then on the AP test, they're going to expect you to give the products of complete combustion, which is always carbon dioxide and water. So in other words, if they supply you with a molecule and they say combustion occurs, they actually mean hydrocarbon combustion. React it with oxygen, and then the products are carbon dioxide and water. And your job will be to then balance that equation. What they'll probably have you do after they have you balance the equation is then give you some enthalpies or heats of reaction and have you do some further calculations with that. Another common type of organic reaction is fermentation. This is the process of making some sort of alcohol, such as ethanol. We typically use a yeast that can digest simple sugars anaerobically, and it produces carbon dioxide as a byproduct of the reaction, and the ethanol is also really a toxic waste product that can kill the yeast when the ethanol alcohol content gets to about 14% by volume. So you have to distill it off of there if you want to get a more concentrated form from that method. Another type of reaction is called the substitution reaction. This is where you start with some sort of a alkane and you want to add something to it, like say a halogen. In a substitution reaction, the halogen basically substitutes for one of the hydrogens, or you can have multiple substitutions. In an addition reaction, you have a double bond, and what happens is you break that double bond and form two new bonds. And again, you can add things like a halogen to it. So for example, shown in this slide, we have ethene and fluorine gas, and we can make 1,2-difluoroethane by breaking that double bond in the middle, breaking the bond between the two fluorines, and then covalently bonding those atoms together. An ether is made by taking two alcohols and then putting some sort of dehydrating agent in there. In other words, an H will come off of one of the OHs, the OH will come off of the other and join together and make water. And it'll join the two alkyl chains together to make the ether. In a similar fashion, if you start with an organic acid and an alcohol instead of two alcohols, you can make an ester. So that's known as esterification, but again, it's a dehydration reaction. Saponification is the process of making soap. This is, if you want to really make real soap, then it has to be a particular formula. But nowadays we make all kinds of various detergents and so forth, and I don't know if they qualify as saponification reactions or not, but basically in the original soap formula, you had a chemical known as sodium stearate. And it is able to, on one end of the molecule, bond very well to water, on the other end bond very well to grease, and so if you run water over it, the water will pull on the sodium stearate, and the sodium stearate will pull on the grease, and it will wash the grease away. Now the last thing I want to talk about, just very, very briefly, is polymerization, the manufacture of polymers. A polymer is a long chain molecule, or it can be a two-dimensional or three-dimensional structure that's made up of many small identical units known as monomers. In other words, you take a small molecule like ethene and you polymerize it, you make polyethylene. So this is where your plastics and things like plexiglass and vinyl, natural rubber, those are all types of polymers. An addition polymerization reaction is where you join a couple of monomers together by breaking double bonds. So this is how you make things like PVC, polyvinyl chloride, PTFE, which is used to make Teflon, a nonstick coating put into pans. A condensation polymerization reaction is kind of like dehydration. You remove water molecules, and this is how they make things like polyester and other synthetic cloth string-like materials. Rubber is a natural polymer manufactured by certain species of plant. It's actually not very good for things like, making tires, but you can cross-link it with the addition of some sulfur. That's known as vulcanization, and then it becomes very, very tough and durable. There's a lot of controversy in the food world over whether or not it's good to use fats that are saturated versus unsaturated versus partially hydrogenated. Basically, what's happening here, if you look at the fat, it's a long-chain hydrocarbon. It's got a lot of singly bonded carbons, but some doubly bonded carbons might be in there too. And basically, if they take the double and triple bonds out, then they make something that we now refer to as a trans fat, and people think that that's not very good for your health. So we try to avoid doing that, although they taste really good, which is why we were doing it before. So that really basically covers our survey of organic chemistry, how to name some of the molecules, maybe how to make some of the molecules. I'm telling you, folks, you could spend years and years studying this stuff. You can take entire college courses, majors, get your PhD in organic chemistry and work in it the rest of your life and still not know half of what there is to know about organic chemistry. So all I've tried to do is give you some very basic introduction to the organic chemistry world, and especially I want you to know how to write some of those formulas in case you see them on the AP test.